Hello everyone, welcome to the series for CAT Quants. Today we're going to start with time and work. Now this is one of the easiest unit from allegations and mixtures section, and I have a really easy method to solve all types of questions in time and work unit. I'm gonna do these two very easy examples today in this lecture, but first of all I'm gonna explain my method. Which I do is, let's say there's a person or male or female and they do a work in X days. And the work I would always represent it by W. And the equation I would form from a statement would be like this. X is the days, then multiplied by M or F, whoever is the person, and this would give me work. It's as simple as that, and we can solve any question. I would show you an example how to do this. If A can do a work in 10 days and B can do the same work in 12 days, then if they work together, how many days would they require? So I'm going to form two equations from the given question. The person A takes 10 days and does a work. This is how I form an equation. And then for the second equation, B does the work in 12 days and it's the same work, W and W. Now it's asking me if they work together. That is A plus B, they work together and they do the work. Now what I need here is X because always the coefficient is the number of days, right? So the coefficient here also would be days. Now I would solve these two equations to find the values of A and B. A would be work by 10 and B would be work by 12, right? Now I would plug it in the main equation, x into W by 10 plus W by 12, which is equal to work, and then x would be equal to, we can cancel the W from here, and we would get 120 upon 10 plus 12 by taking the LCM, and then we would get 120 upon 22. We can solve this here, and we would get around 5 to 6 days in between. So this is a method I was talking about. Similarly, there's another question here, but first of all, you can look at this, what I've done here. Now, coming on to this question, uh, I would introduce you to the concept of negative work, which is being done by C here. Let's form the equations from our statements. A builds a wall in 10 days, so 10 into A is equal to work or wall. B also does it in 5 days, but now C here is destroying the wall in 20 days. So I would like to add a negative sign here because this is negative work. And when I would add or introduce C in equations in which A and B are present, I would write the C with a negative sign. And now what it's asking us, if they start to build a wall together, like A is also building the wall, B is also building the wall, and simultaneously C is destroying it, then how many days would it take to actually put the wall together? So A is building the wall, B is also building the wall, but C is breaking the wall, so minus C, and they're taking X days to do it, and the wall is built. So I'm going to find the values of A, B, and C, which is efficiency only. A is W by 10, B is W by 5, and C is W by 20. We can ignore the negative sign here because we have already introduced this here, or you can put it in any place because we just want to subtract it in the final equation. So X into W by 10 plus W by 5 minus W by 20. Because after all, C is doing negative work, right? You can take it positive here and then introduce it in the negative sign and put it W. Then we're gonna cancel the W from both the sides and we're gonna take the LCM here, which would be 20. 2 plus 4 minus 1, and we would get 20 upon 6 minus 1, which is 4 days. So if A and B are working on the wall and C is breaking the wall with a hammer, so we would get 4 days to build the wall effectively. So this was a very nice method I used to solve almost any kind of question, and we would further bring more questions in the series. Thanks for watching. Keep on watching.